Hi students, now please look at exercise 8.1 of page number 181, question number 1. Question number 1. In triangle ABC, right angle at B, AB equal to 24 centimeter, BC equal to 7 centimeter, determine, in that first question it is sin A, cos A. Okay, in the question it is given a right angle triangle at B, isn't it? So first we will draw a right angle triangle roughly, right angle at B. So we can name it as ABC. Okay, and it is given AB equal to 24 centimeter. AB, that is 24 centimeter. BC, it is 7 centimeter. Okay, now in order to find sin A and cos A, we must get the length of the hypotenuse, isn't it? So here in this triangle, right angle triangle, we will apply Pythagoras theorem. So by Pythagoras theorem, we know that the longest side, length of longest side, isn't it? That is AC. Its square will be equal to sum of the squares of the other two sides. That is AB square plus BC square, isn't it? The square of the longest side, that is hypotenuse square, will be equal to squares of sum of the squares of the other two sides. That is, this theorem is called a Pythagoras theorem. Okay, so in order to find the length of an unknown side of a right angle triangle, we usually apply Pythagoras theorem. Okay students, here AC square we have to find. Here AB, it is given 24. Okay, so AB square it will be 24 square plus BC it is given 7. So BC square it will be 7 square. Okay, now 24 square, what is that? 24 into 24. When we multiply 24 into 24, we will get 576 plus 7 square it is 7 into 7, that is 49. Isn't it students? Now when we add this 576 plus 49, we will get 625. Okay, 576 plus 49. 12. Yeah, that is 625. Okay, now we got AC square equal to 625. Therefore, finally, AC, what will be AC? AC square, that is 625. Therefore, the length of hypotenuse, that is AC, will be equal to square root of 625. Square root of 625, it is 25, isn't it? That is 25 into 25 is 625. So square root of 625, it is 25. Okay students, now the length of hypotenuse we got, that is 25. Now we are asked to find sin A. Therefore sin A, by definition sin, it is what? Sin is opposite by hypotenuse, isn't it students? So that is what? Opposite side. A, here is angle A, isn't it? So opposite of A, it is what? 7. By hypotenuse, we found it is 25. So sin A, it is 7 by 25. Now we are asked to find cos A also. So that is cos A. That is what? By definition, cos, it is adjacent by hypotenuse, isn't it? That is equal to, here A, its adjacent side is 24. So that is 24. By hypotenuse, we found it is 25. Okay students, so the length of sin A and cos A, the measure of sin A and cos A we got, that is 7 by 25, and cos A it is 24 by 25. Okay, please take your notebook students. Similarly, we have one more question here. Now students, we have one more question in question number 1. That is sin C and cos C. We have to find sin C and cos C. In the question it is given a triangle right angle at B. AB it is 24 centimeter and BC it is 7 centimeter. And in the previous question, by applying Pythagoras theorem, we found AC is 25 centimeter, isn't it? So the same figure we can apply here for this question. So sin C, to get sine C, we know definition of sine, it is what? Opposite by hypotenuse, isn't it? So here the angle is C. Okay, so when we take opposite side for this C, we must focus here. This is the angle that we are looking at here. Okay, so opposite of C, it is AB, isn't it? So that is what? AB is the opposite of angle C. So the measure of AB, it is 24. So that is 24 by hypotenuse. Hypotenuse is always same, that is AC, that is 25. Now cos C, cos C, here also it is C. By definition, cos, it is what? Adjacent by hypotenuse, isn't it? So from C we have to find the adjacent side to angle C. What is that? Here is angle C, its adjacent side, it is 7. Hypotenuse, it is the same, that is 25. Hope it is clear. So sine C, that is 24 by 25, and cos C, that is 7 by 25. Okay, please take your notebook, students. Now students, please look at question number 2, exercise 8.1. In figure, a figure is given there, a triangle PQR, right angle at Q, isn't it? In figure, find tan P minus cot R. What is the question? Question number 2, find tan P minus cot R. Okay, measure of PQ, it is given 12 centimeter, and PR it is given 13 centimeter. Okay, PQ it is given 12 centimeter and PR it is given 13 centimeter. We are asked to find tan P minus cot R. Tan P, by definition we know that. What is tan? Tan, it is opposite by adjacent, isn't it, students? Tan, it is opposite by adjacent. So tan P, so we will look at this triangle. Tan P means we have to focus at this angle. So opposite of tan, it is QR, whose measure is not given, isn't it? So first we have to find the measure of the length of QR. Okay, since tan P we have to apply for this question. By definition, tan P means that is opposite of P, that is QR, by adjacent. Adjacent is what? PQ. Okay, so QR, the length we don't know. So first we need to find out the length of QR. For that we will apply Pythagoras theorem in triangle PQR. Okay, so by Pythagoras theorem, what is how can we apply Pythagoras theorem in triangle PQR? It states that square of the longest side, isn't it? Square of hypotenuse. What is hypotenuse here? That is PR square, isn't it? Hypotenuse is PR. So square of hypotenuse means that is PR square will be equal to sum of the squares of the other two sides, isn't it? So the other two sides are what? PQ and QR, isn't it? Its squares, sum of the squares of other two sides, that will be equal to square of the hypotenuse. This is what Pythagoras theorem states, isn't it? Now when we apply these values here, PR, it is given. PR is given, that is what? 13. So PR square, it is 13 square. Okay, equal to PQ, it is given. PQ, it is given 12. Isn't it, students? 12 square plus QR. We have to find out QR square. Okay. Yeah, PQ and PR is given and we have to find QR. Okay, fine. Now we will first square this. 13 square is 13 into 13, that is 169, equal to what? 12 square. 12 square means that is 12 into 12, that is 144, isn't it? Plus QR square, that is what we need to find out, isn't it, students? Now we will take 144 to the other side. Okay, so that will become 169 minus 144, isn't it? That is what? QR square. 169 minus 154, when we subtract this we will get 5, 2, isn't it? that is 25 is QR square. Okay, that is QR square equal to 25. Therefore, QR square equal to 25. So therefore, QR will be equal to square root of 25. What is square root of 25? That is 5, isn't it? Okay, students. So now we got the length of QR, that is 5. Okay, now we will look into this question. Find TP minus cot R. That is what we have to find, isn't it? So we have to find tan P minus cot R. So first we will take what is tan P. Tan P, looking into P, from P when we look at opposite side, that is 5. By definition, tan it is opposite by adjacent, isn't it? So opposite by adjacent of P, it is adjacent of the angle P, that is 12. Okay, so that is tan P, it is 5 by 12. Okay, similarly cot R. By definition of cot, it is what? Adjacent by opposite, isn't it? Here it is cot R. So we need to focus to this angle. Cot R means that is this angle. From R, by definition of cot, it is what? Adjacent. What is adjacent to this angle? 5. Okay, adjacent by opposite. What is opposite of this angle? That is 12, isn't it? Opposite of angle R. Here it is 12. So that is what? 5 by 12. Okay, students. Now we got tan P and cot R. So therefore, finally, tan P minus cot R will be equal to tan P, it is what? 5 by 12 minus cot R. Cot R is also 5 by 12. Okay, so that is 0. Okay, students. So therefore we found tan P minus cot R is 0. Okay, hope it is clear. Please practice the basics of this chapter, the definition of sine, cos and all, the inverse functions. So this exercise, it is going to be very easy for you students. Okay, now we have next question we'll discuss. Thank you.